Good morning. Welcome to Trinity online classes. I am Vivian Suresh Kumar, lecturer in mathematics. A square is inscribed in the circle x square plus y square minus 6x plus 8y minus 103 equal to 0 with its sides parallel to the coordinate axis. Then the distance of the vertex of the square which is nearest to the origin is first, a square is inscribed in the circle with its sides are parallel to the coordinate axis. First solution. First we find the center and radius of the circle. Observe that the given circle be x square plus y square minus 6x plus 8y minus 103 equal to 0. This is of the form x square plus y square plus 2gx plus 2fy plus c equal to 0. Here x quotient is 2g, here x quotient is minus 6, therefore g equal to minus 3. Here y quotient is 2f, here y quotient is 8, f equal to 4. Here constant c equal to minus 103. Center of the circle. Center of the circle C1b. Actual formula is minus g comma minus f. That is minus of minus 3 minus f. That is minus 4. G is minus 3. Minus g means 3. F is 4. Minus f is minus 4. Radius of the circle is r1 equal to square root of g square plus f square minus c. That equal to square root of, here g is minus 3 whole square plus 4 whole square minus of minus 103. The value of c is minus 100. That equal to square root of 9 plus 16 plus 103. That equal to 9 plus 16, 25, 25 plus 103, that equal to root 128 is nothing but square root of 64 into 2. 128 is the product of 64 into 2. 65 got outside 8 root 2. Therefore, R1 equal to 8 root 2. This is the radius of the circle. This is the center of the circle. Actually, a square is inscribed in the circle with its sides are parallel to the coordinate axis. First, this is a square. The square is inscribed in the circle. The square is A, B, C, D. This is the equation of the circle. We know that square is inscribed in the circle. The point of intersection of the diagonals, is the center of the circle. We know that the point of intersection of square is inscribed in a circle. Point of intersection of the diagonals is the center of the circle. Indirectly, the diagonal is the diameter of the circle. Indirectly, the diagonal AC is the diameter of the circles, and diagonal BD is also diameter of the circle. This is one. This is another thing. These are the two diameters and two diagonals of the square, and it is two diameters of the circle. We know that square is inscribed in the circle. The intersection of the diagonals is the center of the circle, and the diagonals are the diameter of the circles. This is C1. Here, square is inscribed in the circle. Next point, its sides are parallel to the coordinate axis. Maybe this is x-axis. Here center is C1 is known 3 comma minus 4 that lies in fourth coordinate. Maybe suppose this is x-axis. Suppose this is y-axis. This is x-axis and this is y-axis, because with its sides are parallel to the coordinate axis. This is x-axis. The two sides AB and DC are parallel to x-axis, and also this is y-axis. AD and BC are parallel to y-axis. This forms a right angle. This forms a right angle. Therefore, the angle made by the line with x-axis is, this is also 90 degrees, this is 45 degrees, this is 45 degrees, this is 45 degrees. These two are perpendicular, these two are perpendicular, and also these two are perpendicular because it is a square. First, angle of inclination of this line AC is 45 degrees. Angle of inclination of, because it is the diagonal and also diameter. This line, we know that angle between the adjacent sides of the square is 90 degrees. This is the one diagonal is the angular bisector. Therefore, 90 divides into 2 45s. This is the 45 degrees. This is also 45 degrees. This line is parallel to this line. X-axis is parallel to the line AB. The diagonal forms 45 degrees with the side. Automatically, the diagonal forms the 45 degrees with the x-axis, because x-axis and these sides are parallel. In this case, we know the point C1. We find the coordinates of the point A and point C. Actually, we need the distance of the vertices of this square, which is nearest to the origin. Which is nearest to the origin, you don't know the line, y-axis is here or here. That's why to find all the vertices of the square and find the distance, and also find the distance from origin to the each vertex, then we can say we've got the nearest point, we got the nearest vertex from the origin. That's why first we prefer to find all the vertices of a square. Here we know the center of the line circle. That means a point on AC is C1. We know the one point on C1, and the angle of inclination is known. And the distance is, this is R. That side is R, this side is, and the distance is R. We need another point in the same line. We need another point in the same line. One point is known, that line, and the distance of the fixed point to required point is known. By using symmetric form, we find the coordinates of the remaining two. We find the coordinates of the remaining two. Here, angle of inclination, we know that the symmetric form is x minus x1 by cos theta equal to y minus y1 by sin theta equal to mod r. X minus x1 by cos theta equal to y minus y1 by sin theta equal to mod r, or x minus x1 by cos theta equal to y minus y1 by sin theta equal to plus r minus r, where r is the distance between the points and theta is the angle of inclination of the line with the x-axis. Therefore, x1 comma y1 is the known point. Actually, symmetric form use the situation. One point is lies on the line. The fixed distance is not the required point find out by using the help of these situations using the symmetric form. Here theta equal to 45 degrees at x1 comma y1. The point is C1 is 3 comma minus 4. This is x1, this is y1. Therefore, x minus 3 by 2x minus 3 by cos 45 degrees equal to y minus of minus 4, y plus 4 by sin 45 degrees equal to plus or minus, here radius is, the distance of radius is 8 to root 2, 8 root 2, that equal to 8 root 2. First case, x minus 3 by the value of cos 45 is 1 by root 2, that equal to y plus 4 by the value of sin 45 is 1 by root 2. Here that equal, first we take 8 root 2. Later we take minus 8. In this case, root 2 into x minus 3 equal to root 2 into y plus 4, that equal to 8 root 2. Compare these two. Therefore, root 2 into x minus 3 equal to 8 root 2. Root 2 cancel. X minus 3 equal to 8. X equal to 8 plus 3. Therefore, x equal to 11. and also root 2 into y plus 4 that equal to 8 root 2. Root 2 cancel, y plus 4 equal to 8, y equal to 8 minus 4, y equal to 4. Therefore, the first coordinate is 11, 4. This is the one of the coordinate, and that means one of the coordinates of the points vertices. Next, x minus 3 by, we take x minus 3 by root 1 by root 2, x minus 3 by 1 by root 2 equal to y plus 4 by 1 by root 2 equal to minus 8 root 2. Root 2 into x minus 3 equal to root 2 into y plus 4 equal to 8 root 2. Sorry, minus 8 root 2. Root 2 into x minus 3 equal to minus 8 root 2. Root 2 cancel. X minus 3 equal to minus 8. X equal to minus 8 plus 3. X equal to minus 5. And root 2 into y plus 4 is also equal to minus 8. Comparing these two and comparing these two. Root 2 cancel. Y plus 4 equal to minus 8. Y equal to minus 8 minus 4. Y equal to minus 12. Another vertex is minus 5, minus 12. Here, this is one of the line 45 degrees. The angle between these two lines is 90 degrees. Therefore, angle of inclination of this line, another line is 135 degrees. 90 plus angle of this line is 45 degrees. Angle of inclination of another line is 45 plus 90. This angle of inclination is 135 degrees. By using the same system, we find the remaining two vertices. By using the symmetric form is x minus x1 by cos theta equal to y minus y1 sin theta equal to plus or minus yr. Here theta equal to 45 degrees, that is the first case we find. Another is theta equal to 135 degrees. Another theta equal to 135 degrees. Using the formula x minus 3 by cos 135 degrees here, because it is also center is known and one of the point and BD is known, we find the vertex B and vertex D, the distance are known, or if any one of the line for one point is known, the distance is known, we find another point on that line by using the symmetry form. Same condition you apply that. Here vertex or one vertex is 11, 4, maybe this is C. Because this is first coordinate, C is 11, 4. This is third coordinate. Suppose we like made this third coordinate, this is A, named as A. First you applying the theta equal to 45 degrees. We find the two vertices. One vertex is A, one vertex is C. C is 11, 4 and vertex A is minus 5, minus 12. By using 135 degrees angle, we find out that we got the values of vertex B and vertex D. In this case, x minus 3 by cos 130 degrees equal to y plus 4 by sin 135 degrees equal to plus r minus r. Here radius of the circle is 8 root 2. 8 root 2. We know that cos 135 degrees equal to cos 90 plus 45. We know that cos 135 degrees equal to cos 90 plus 45. Cos 90 plus theta, which is second coordinate. Second coordinate cos is negative. 90 becomes cos, what is sin? Simply sin 45. The value of sin 45 is 1 minus 1 by root 2. Sin 45 is 1 by root 2, minus is there, minus 1 by root 2. Simply sin 135 degrees. Sin 135 degrees is sin 90 degrees plus 45. 90 degrees plus 45, 90 plus theta, which is second coordinate. Second coordinate sin is positive. 90 sin will be converted into cos E. Cos 45, that equal to 1 by root 2. These values are help to calculation. X minus 3 by cos 135 is minus 1 by root 2. That equal to y plus 4 by sin 135 is 1 by root 2. Sin 135 is 1 by root 2. That equal to plus or minus 8 root 2. Minus is taken top, minus root 2 into x minus 3 equal to root 2 into y plus 4 equal to plus or minus 8 root 2. Plus or minus 8 root 2. Therefore, We take first position minus root 2 x plus 3 equal to root 2 y plus 4 equal to 8 root 2. Minus root 2 into x minus 3 equal to 8 root 2. Root 2 cancel. X minus 3, this minus is taken that side. X minus 3 equal to minus 8. X equal to minus 8 plus 3. X equal to minus 5. Here root 2 into y plus 4 equal to 8 root 2. Root 2 cancel. Y plus 4 equal to 8. Y equal to 8 minus 4. Y equal to 4. Here the point is minus 5 comma 4. Here the point is minus 5 comma 4. Next the remaining part is minus root 2 into x minus 3 equal to root 2 into y plus 4 equal to minus 8 root 2 equal to minus 8 root 2. That's why minus root 2 into x minus 3 equal to minus 8 root 2. Root 2 cancel. Minus cancel. X minus 3 equal to 8. X equal to 8 plus 3. Therefore x equal to 11. And also root 2 into y plus 4 equal to minus 8 root 2. Root 2 cancel. Y plus 4 equal to minus 8. Y equal to minus 8 minus 4. Y equal to minus 12. Here the point is 11 comma minus 12. 11 comma minus 12. This point is generally lies in the second coordinate minus x comma y coordinate. That way the point will be taken as the name D. And the vertex 11 comma minus 12. Here y coordinate is in the point is taken as the name B. In this case we find the vertices, 4 vertices of the square A, B, C. We check which one of the point is nearest to the origin. We find the distance from origin to the each point. Therefore, the distance from OC equal to square root of, we know that the distance from origin to the point x1 comma y1 is square root of x1 square plus y1 square. That is square root of 11 square plus 4 square. That equal to square root of 121 plus 16. That equal to square root of 137. Here the distance of OA from 5 square minus 5 whole square, that equal 25 plus 144, that equal to root 169. This is the root 137, the value is, this is root 169. OD equal to square root of minus 5 whole square plus 4 whole square, that equal to square root of 25 plus 16. 35 plus 6 root 41. And OB equal to square root of 121 plus 144. This is highest, this is the least value. Root 141 is the least value. Therefore OD equal to root 40. It is least value compared to this. Otherwise we simplify this. 121, 141, 265. Here the distance from origin to C is root 137. The distance from origin to vertex A is root 169. The distance from origin to point D is root 41. The distance from origin to B is root 265. Therefore this is the least value. The nearest point on the vertices of the square is D. D is the nearest point. The point is minus 5 comma 4. Actually a square is, question is a square is inscribed in the circle x square plus y square minus 6x plus 8y minus 103 equal to 0 with its sides are parallel to the coordinate axis. Then the distance of the vertex of the square which is nearest to the origin. First we find the center and radius of the circle. We know that diagonals of the square is the diameter of the circle, and the point of intersection of the diagonals is the center of the circle. The angle between the adjacent sides are 90 degrees in the square. One diagonal is angular bisector. That coordinate axes are parallel to the sides. This is x-axis, this is x-axis parallel to AB and DC. and the diagonal frames, one diagonal forms 45 degrees with the x-axis and the another diagonal forms 135 degrees, the 45 plus 90, 135. These are known concepts already. In this case, we find the all vertices of the squares. First, we find the vertex of A and C by using the help of symmetric form. Which situation symmetric form use means we've known the one point on the line and the fixed distance known. We got the another point in that line by using with the help of symmetric form. The symmetric form is x minus x1 by cos theta equal to y minus 1 by sin theta equal to mod r, where r is the distance between the points. Mod r means one point is like this side, one point is like that side. We using this help. One angle is there 45 degrees. We got the two vertices, they are two vertices, and another diagonal forms as 135 degrees. We find the two vertices, the vertices are B and D. Therefore, these are four vertices. Actually, we need the distance of the vertices of the square which is nearest to the origin. We find the every distance from origin to the every vertices. These are the four distances. The least distance is root 41. Therefore, the vertex D minus 5, 4 is the nearest point to origin. This is the problem. If a circle of radius capital R passes through the origin, if a circle of radius capital R passes through the origin O and intersects the coordinate axis at A and B, that circle passes through origin and having radius R, intersects the coordinate axis at the point A and B, then the locus of the foot of the perpendicular from O on AB, the foot of the perpendicular of origin on segment AB is, that means locus. We need locus. Solution. Actually, the radius of the required circle B, the radius of the circle B capital R, and it passes through the origin and also intersects the coordinate axis. That's why. This is the circle, passes through origin, this is x-axis, intersects coordinate axis, this is y-axis, this is x-axis, this is y. Then the vertex, one of the vertex B intersecting circle and x-axis, the point mentioned as point A, intersection y-axis and the circle mentioned as point B. This is the origin. This is origin O. If a circle of radius capital R passes through origin and intersects the coordinate axis, that means cuts the coordinate axis at vertex A and vertex B, join AB, this is join AB and join AB. Then the locus of foot of perpendicular from O on AB, the foot of the perpendicular from O on AB is, this is the foot of the perpendicular from O on AB, let P. Let P the foot of the perpendicular of O on AB. This is foot of the perpendicular. This is the line AB. This is the foot of the perpendicular. We find the foot of the perpendicular. That means we find the locus of the point P. Here, a circle of radius R. This is the radius. The distance from center to, the distance from origin to center is, point is radius capital R. If a circle of radius R passes through origin O and intersect the coordinate axis A and B, then locus of the foot of the perpendicular is, let the locus P, H comma K be the, let H comma K be the foot of the perpendicular. H comma K be the foot of the perpendicular. Perpendicular from O to line AB. O to line AB. Therefore, the slope of first we find the slope of OP. First we find the equation of AB. First we find slope of AB. Slope of OP. Here O is 0, 0. P is H, K. O is 0 comma 0, P is H comma. Slope of OP equal to distance between the slope of between the 2 points y2 minus y1 by x2 minus x1 k minus 0 by h minus 0 that equal to k by h. There we know that OP perpendicular to AB. OP perpendicular to AB. Slope of AB equal to, we know that the two lines are perpendicular. Product of their slopes is equal to minus 1. Therefore, slope of AB equal to minus 1 by slope of OP. That equal to minus 1 by slope of OP is k by h. That equal to minus h by k. Therefore, slope of AB is minus h by k. Therefore, we find the equation of AB passing through the point P h comma k is known and slope of AB is known. Therefore, the equation of line AB B whose slope is m equal to minus h comma k. Slope m is minus h by k, comma point is h comma k. Therefore, this equation is y minus y1 equal to m into x minus x1. Therefore, y minus k equal to m minus h by k into x minus h. That equal to yk minus k square equal to minus hx, cross multiply k into y, yk minus k square equal to minus hx, minus of minus plus h square. Converse these are same side, minus hx converts this side, hx plus ky minus hx it converts plus hx plus ky minus k square go to that side, that equal to h square plus k square. Hx plus ky equal to h square plus k square. This is the equation. Dividing the equation by h square plus k square, hx by h square plus k square plus ky by h square plus k square equal to 1. Divide the equation by h square plus k square, hx by h square plus k square plus ky by h square plus k square equal to 1. Then it convert the intercept form x by h square plus k square whole divided by h plus y by h square plus k square whole divided by k equal to 1. This is the line AB in intercept form. We know that this line is intercept form. X by A plus Y by B equal X by A plus Y by B equal to 1. This is the x-intercept is A, y-intercept is B. The coordinate is A comma 0 and the coordinate is 0 comma B. Therefore, here x-intercept is h square plus k square by h and y-intercept is x-intercept is and y-intercept is h square plus k square by k. Therefore, the coordinates of point A, here x-intercept is A, the coordinates of point A is A comma 0. That's why the coordinates of point A is h square plus k square by h comma 0 and the coordinates of point B, actually the y-intercept is B, therefore the coordinates of B is 0 comma B, therefore 0 comma h square plus k square by k. Here we find the coordinates of A and coordinates of B. We know that given the radius is R. We know that the radius is R. This is the diameter of the circle. A circle passes through the origin and intersect the coordinate axis AB. Automatically AB is the diameter of the circle. We know that the radius of the circle is capital R, therefore diameter of the circle is 2R. The length, we know that by data, we know that the length of AB is the endpoints of the diameter. Circle passes through the origin, intersects the coordinate axis. The joining the intersection of the coordinate points is the diameter of the circle. This is the P is the foot of the perpendicular. Maybe it is center is anything. Center. P is the foot of the perpendicular from origin to AB. That's why AB equal to length of the diameter AB equal to 2 into capital R, where R is the radius of the circle, therefore length of the diameter is 2 into R. The distance between the 2 points AB is, we know that the distance between the 2 points is squaring on both sides. Squaring on both sides, AB square equal to 2R whole square. AB square means the distance between x2 minus x1, that means h square plus k square by h minus 0 whole square plus 0 minus h square plus k square by k whole square equal to 4r square. That means h square plus k square by h whole square plus h square plus k square by k whole square equal to 4r square. Equal to 4r square is h square plus k square by h square. h square plus k square by h square, here whole square. h square plus k square by h whole square means h square plus k square whole square by h square plus h square plus k square whole square by k square equal to 4r square. Common, h square plus k square whole square will be taken as common. 1 by h square plus 1 by k square equal to 4r square. We take LCM, h square plus k square whole square. The LCM is h square into k square. h square means k square plus h square equal to 4r square. This is the LCM of this. This is one. Similar, h square plus k square whole square into 1 whole cube, that equal to 4r square h square k square. This is the locus point. H comma k is the foot of the perpendicular in particular point. The locus of point P B. The locus of point P B, x square plus replace h by x, replace k by y, x square plus y square whole cube equal to 4r square x square y square. This is the locus. In this problem, if a circle of radius r passes through origin and intersect the coordinate axis at A and B, that's why that circle is passes through origin and intersect the x-axis at point A, y-axis is at point B. Then the locus of the foot of the perpendicular from O to and AB is, the locus from O to foot of the perpendicular from O to line AB is P. Let we take the coordinates of point B, h comma k. We know that foot of the perpendicular means the line OP is perpendicular to AB. First we find the slope of OP. We know that the two lines are perpendicular. Product of the slopes is equal to -1. Therefore the slope of AB equal to these two lines are perpendicular. First we find line slope of OP. The slope of AB is -1 by slope of OP. We find the equation of the circle. We find the equation of the line AB. We know that in this case slope of the line will be known and the point on the line will be known. Therefore the equation of the line becomes, then the line will be converted into intercept form, because the x-intercept is A, y-intercept B, then the coordinates A is A comma 0, coordinate B is 0 comma B. That's why the coordinate A is x-intercept comma 0, the coordinate of B is 0 comma y-intercept. We know that the given help is the radius of the circle is capital R. We know that circle cuts the coordinate axis and passes the origin. The cutting points are ends of the diameter. Therefore, AB is diameter. We know that radius is R. The length of the diameter AB equal to 2 into radius. Solve this equation. We got the locus. H comma k is the fixed point. Replace the locus point. In place of h is x. In place of y, the required locus is x square plus y square whole cube equal to 4r square into x square y square. ABCD is square of unit area. A circle is tangent to two sides of ABCD and passes through exactly one of its vertices. The radius of the circle is, here ABCD is a square of unit area. We know that the area of the square is x square if the area of the square is x square. If length of x square, if s is the length of the side, here ABCD is a square of unit area, that means x square equal to 1, s equal to plus or minus 1. Here there is no negative value, s is the length of the each side, therefore s equal to 1. ABCD is a square of unit area, that means the length of each side, the length of each side, the length of each side be 1. ABCD is a square of unit area, that indicates area is 1 unit and length of the each side is also 1. A circle is tangent to two sides of ABCD. Here ABCD is square. A circle is tangent of two sides of ABCD and passes through exactly one of its vertices. Suppose this is the circle. A circle is tangent to two sides. This is the one side. Two sides tangents. This is another side. This will be named as point A. A circle is tangent to two sides of ABCD and passes through exactly one of its vertices, and one vertex may be lies here, lies on circle. Only one vertex passes through exactly one of its vertices. That one vertex is C, named as that is B. This is D. This is ABCD. A circle is tangent to two sides of ABCD. This is one tangent AB. This is another tangent AD. Two tangents. One tangent is AB. One tangent is AD. And passes through exactly one of its vertex. Passes to the vertex B, C, passing through the point. The radius of the circle is, then we find the radius of the circle. Radius of the circle. Here we know that square of unit area, okay, square for diagonal adjacent sides are perpendicular to each other. Square for adjacent sides are perpendicular to each other. That's why in this problem, suppose we take these two lines are coordinate axis. Maybe this is x-axis, this is x-axis, this is y-axis. Because square for adjacent sides are perpendicular, these two tangents are perpendicular, we take this is x-axis, this is y-axis, and automatically this becomes the origin. This is x and y-axis. We know that the length of the side of the square is 1 unit. Therefore, this length is 1 unit. And also this length is 1 unit. This length is 1 unit. This length is 1 unit. The point B lies on x-axis. We know that any point lies on x-axis, its y-coordinate is 0. Therefore, the coordinates of the point B 0, 1, 0. 1, 0, because any point lies on x-axis, y-coordinate is 0. Here A be the origin, O 0, 0. Any point lies on y-axis, its x-coordinate be 0. Therefore, the coordinates of point D be 0, 1. The here length is 1. It is C. By the definition of the x-coordinate, the length is 1. By the definition of the y-coordinate, the length is 1. We got the four. Suppose in this case, square for adjacent sides are perpendicular to each other. These two are tangents of the circle. These two may be taken as coordinate axis. Therefore, the vertices is, one of the vertices is origin. Another B is 1, 0. C 1, 1 and D 0, 1. This is the concept of the radius. But then radius of the circle is, we know that previous concept, any circle touches the both the coordinate axis, center B taken as any circle touch, this is the perpendicular, this is perpendicular, center C be taken as R, R. Center will be taken as R, R. The circle is X and radius is R. In previous concept, we know that any circle touches the coordinate axis, the center is R, R and radius is R. Here we take center of the circle C1, center of the circle is R comma R and radius equal to R and radius equal to R. Then we find the equation of the circle. Equation of the circle. Circle is x minus r whole square plus y minus r whole square equal to r square. Here center is h comma k and radius r. The equation of the circle is x minus h whole square plus y minus k whole square equal to r square. Here we find the radius of the circle. First we find the equation of the circle. But here one information is that equation of the circle passes through the C1 comma 1. Passes through the C1 comma 1. Simplify. Therefore, thus point C. This is the equation of the circle. Point C. Point C 1 comma 1 lies on equation 1. Therefore, the point must satisfy the equation of the circle. Therefore, 1 minus r whole square plus 1 minus r whole square equal to r square. This is of the form a minus b whole square. 1 plus r square minus 2r plus same formula a minus b whole square 1 plus r square minus 2r. That value r square comes this side minus r square equal to 0. R square cancel. R square minus 2r minus 2r minus 4r 1 plus 1 2 equal to 0. There is no factors in this equation. There is no factors. By using the quadratic form r equal to minus b. Here b is minus 4 minus here b is minus 4 minus b plus or minus square root of b square minus 4 whole square, that is 16 minus 4 AC 4 into 1 into 2 by AC 2 into r square quotient is 1 minus of minus plus 4 plus or minus root of 16 minus 8 by 2, that equal to 4 plus or minus root 8 by 2, that equal to 4 plus or minus 2 root 2 by 2. We take common 2 plus or minus root 2 by 2, 2 cancel, 2 is common, 2 plus or minus root 2, r equal to 2 plus or minus root 2, r equal to 2 plus or minus root 2. Here the length of the maximum side is a 1. This is the distance from center to radius. Radius is always less than 1. That's why r equal to 2 plus or minus 2, two options, r equal to 2 plus root 2, r equal to 2 minus root 2. Suppose r will be take 2 plus root 2, square of unit area, that means largest, go to largest. This is not possible because 2 plus root 2 is the highest length of the side of the square. Therefore, the radius of the required circle be r equal to 2 minus root 2. The radius of the required circle is r equal to 2 minus root 2. ABCD is a square. Radius of the required circle is r equal to 2 minus root 2. ABCD is a square of unit area, therefore length of the each side is 1. We know that the angle between the adjacent side of the square is 90 degrees. That why these two are taken as coordinate axis, because a circle touches the two tangents and passes through one of the vertex. This will be taken as coordinate axis automatically. The points are 1, 0, 1, 1, 0, 1. Therefore, we know that any circle touches the coordinate axis, center is r, 1. This is the equation of the circle touching both the coordinate axis. But the circle passes through 1, 1. We got the value of n. Two options. Therefore, the radius, two options. First option is here. The length of the each side is 1. Therefore, r plus 2. Therefore, the radius of the required circle is 2 minus root 2 only.